Direct variation day 3, you can cheer because there's no direct variation day 4. Woo! Yay! Do you think they'll know we planned that?
You're not supposed to say that. You heard that, no you didn't.
Okay, so we have to write a couple things down. The difference between today and day 1 and day 2 is there's still direct variation, also known as direct proportion. But there's this other type of graph too called inversely. And we want to be able to tell the difference. Which again, I think the most confusing part is just why it has so many names and why is it doing that. So directly proportional, you also could say directly or direct variation. And then inversely. Are you writing in these 2 top boxes?
We can make those things.
Maybe a small one in
And those
They're going to look different. So it can be small. Does anyone remember what the origin is? Right, the middle, the 0, 0 spot. So this is not a surprise to us. It has to go through the origin, the middle, in order to be called directly proportional or direct variation. And who was our mechanic again?
Her.
Oh yeah, Justin. Justin's working at a steady increase. 1 hour, $30. 2 hours, $60. A steady increase. Or, let's say you decide to go to a movie every day. 1 movie, $8. That would be down because I'm losing money. 2 movies, $16. 3 movies, $24. 4 movies, what am I at? 32?
No candy money?
No candy money for you. So it's either a steady increase or a steady decrease. Has to go through the middle. That's not a surprise, right? Been doing that for days. The other weird one, did you see this? A curve. What? We've never done a curve before. That approaches each axis. Fancy word axes, but never touches it. So it looks, it gets really close to X, but it never touches it. It gets really close to Y, but never touches it. And it can be in any quadrant. So this would be positive numbers. It could happen down here where there's the negative numbers. So the first thing we want to be able to do is identify which one is which. Basically, is it direct or inverse? Do you think you can do it by looking at it? Is it straight going through 0? You call that direct. Is it curved, getting close to the lines but not actually touching it? You call that inverse. Yes?
Yes.
So if I held up a card of one of these, you could call it the right name. 2 people said yes and 20 people stared at me.
Yes.
Oh, thank you. Ellie and Allison agreed. So when you look at all of those other ones, I'm basically just trying to give it the right name. What do you think I would call the top left one? Direct. Goes through 0, steady increase. What happened to the negative? It's pretty much like Justin's mechanic job. he isn't making negative dollars, so they just didn't even put that on. Here's a curved one, inversely. We just call it inverse. Going through zero, steady increase. Now, why is it a little more flat, you think?
It's not increasing as much.
It's not increasing as much. Like maybe this is a lemonade stand. They're not getting $30 for a cup of lemonade. Maybe 50 cents. So their money that they're getting doesn't go up as fast as Justin's, but it's still going up.
That's a green one.
So what would I call this one?
Direct.
Are you labeling yours?
I just put D on.
As long as you know what it means. How about this one? I think mine are out of order now. Yours goes to here, right?
Yeah.
Ooh. Decrease, is that okay?
Yeah.
Somebody's spending money instead of making money. Direct. How about this one? I think it says walking speed.
Yeah.
Hours and miles. The more hours you walk, the further you go. Why isn't there any negatives?
Because you
can't
walk
walk.
You can't walk there.
Well, you can walk backwards, but that.
But negative time is the problem.
Oh yeah.
As soon as you take one step, you're already in the positive. You could stand at zero and be still forever. Bryn.
Technically, couldn't you have like 6 days, like you have an hour before you're gonna start, because you like count up, like from like start at negative and then go up, and then once you get to zero, you have to start walking. That thing.
Yeah, but I haven't actually moved yet.
Um,
You see what I mean?
Yeah.
So you're still basically at zero. Okay, so that's how you can tell the graphs apart. Do we feel okay about the graphs? Okay, part 2 is I need to be able to tell the equations apart, which might be the trickiest one. Again, this one has been with us for day 3 now. Y equals kx. I will write down the equation. What's k again?
Slope.
The slope. Where's the y-intercept?
It's just plus 0, that's hidden.
Plus 0. So that part hasn't changed, right? You agree with me? Hasn't changed. The inversely one, which is new to us, has changed a little bit. We haven't seen one that looks like this before. Y equals k over x. What's k again? So the slope is on top of x in these weird inverse ones. Bryn. Did you write down what it looks like?
Do you have to like divide them?
If you were going to solve it, you would have to divide, yes. Good question. So, similar to 2 days ago, when we had to find the ones in this box that were direct, now we're looking for, are they direct or are they inverse? So it's like taking it to the next level. I feel most confident about direct, so I always look to see if I can find any of those first. How do I know it's direct again?
If it goes through the origin.
If it goes through the origin or the 0. I see 2 in the top row that could work. Maddie, The second and the third one? So where would I start if I was gonna graph it?
-21.
Why is 21 in front of x?
Because it's a slope.
That's my slope. Where am I gonna start?
0.
Yeah! They didn't write it there because it is 0. What do we know about graphs that go through 0? Bryn,
Will the 48 over y equals x be inverse?
let's just try to do the direct one first.
Oh,
But I saw you wrote something.
then the -32x equals y.
Okay, what if we switched it around like this?
It's the same thing.
Oh, it looks the same as this one now. Who puts y at the end? That just makes us confused. What about the middle row? I know it looks silly right now, but what if I did the opposite of minus and added on both sides? Now is it right?
Yeah.
Start at 0, rise 39, run 1. What if I did the opposite of minus 25x and add 25x? Same thing. What if I did the opposite of minus? Do you think there's any at the bottom row that's going to work?
No.
I don't think so.
What about that one?
Okay.
xy equals 2.
How am I going to unstick this x from the y?
Divide by x.
Divide by x, she says.
And then that'll be inverse.
Who just said that? Me. Bryn says now it is inverse. How in the world did she know that? Maddie, was you?
Yeah.
Maddie said now it is inverse. Sorry, someone said that. How in the world did you know that?
Because inverse says that it's the slope divided by x.
Inverse says the slope divided by x. Look at that. Better call this one inverse. Do we see any others that might be inverse?
All the ones we didn't mark as direct. Oh.
It's not quite that easy, Isabel. Bryn.
The -43 over x equals y.
Wait a second. Slope divided by x. Here's one. Divided by x. Divided by x. Bryn. She said it had to be slope divided by x. Are there any left?
No.
What?
They're all divided by y.
Good observation. Divide by y puts them in this neither category. It doesn't fit into either one. There was a lot of those. Whew. Kind of like if I went back to my graphing one, and I know this wasn't on your paper. What would I call this one?
No, that's direct.
This is direct because it's going through 0, 0. But what if it started here?
Then it
Neither.
Then it would be neither. It's not direct or inverse. That happens sometimes. Is it still a graph?
Yeah.
Sure is. just doesn't fall under any category. That's okay. Third option is, ooh, this one's a little bit weird. If they give you, oh, what do I want to call it? A chart, but it really is just an XY chart. Table, XY table. So, I'm trying to think of how to make it more clear. The divide is the key word. And I'm going to show you before maybe you write something. If you divide x by y and you get the same number every time, that's how you know it's direct. So negative 9 divided by negative 9, 1. Negative 8 divided by negative 8, 1. 12 divided by 12, 1. So, how do I want to say it? Y divided by x is the same number. Remember when I told you a couple days ago that this was my least favorite thing to teach? Because sometimes it's just hard to put it into words. Drake.
Is our homework gonna be like picking stuff? Or like a thing like we've been doing?
Like if it fits into each category?
Yeah.
Mm-hmm. On the inversely side, it's if you multiply x by y and get the same number. So on this chart, it says negative 25 times negative 2, 50. Negative 5 times negative 10, 50. Negative 2 times negative 25, 50. So, keyword divide, keyword multiply. So you kind of have to do a little experiment almost on your XY chart to see. Is it going to be multiplying? Is it going to be dividing? Just waiting for people to write.
You already been in here.
Math is just so fun, Bryn. What can I tell you?
Yeah.
Math is just so fun. Is that enough time? So when we look at the charts, we're trying to decide if we're dividing, is there a pattern, or if we're multiplying, is there a pattern? So it's kind of a little guess and check to start. 5 times 25, anybody? 125. Negative 12 times negative 60. 500. So do you see when I multiplied, I didn't get the same answer both times? Okay, so now let's try dividing. 25 divided by 5, 5. Negative 60 divided by negative 12, 5. 35 divided by 7, 5. Negative 40 divided by negative 8, 5. So which one did we write down for if you divide with the constant pattern?
Direct.
Oh, look at that. Direct, divide. Direct, divide. DD. Isabel?
I was really confused on this whole thing until we actually did it. I was like, what?
I know. Sometimes the words, that's what's kind of hard for me, is to explain it in words.
Yeah.
Because sometimes the words aren't actually helpful. Okay, how about over here? 24 divided by 6, 4. 49 divided by 7, 7. Ugh, the dividing didn't work. Let's try the timesing. 24 times 6. Whew, I haven't done a side problem in a while. 144? Thanks. 49 times 7.
Guessing.
28, 34. Did anybody get 343? What?
Neither.
Who said that?
That's what I was thinking too, neither.
Maddie, I hear your voices from everywhere today. It sounds like it's coming from over here. Neither, she said. Neither strategy worked. Remember, like the graph that started at 4? It's a graph, but it wasn't a direct or an inverse graph. Sorry, Maddie. I think your voice is just following me around.
Maybe it is.
Maybe it is. Should we try multiplying or dividing? Negative 6 times negative 4. 12 times 2. Oh, this is looking good. Negative 8 times negative 3. Negative 1 times negative 24. Which one had multiplied? Should we try multiplying or dividing first? 49 divided by 7. 91 divided by 13. It is 7? I better guess and check. Look at that. This is looking good. Negative 42 divided by negative 6. 203 divided by 29. Is it 7? I'll guess and check.
I'll just guess.
Divide. Direct. Yay. So our whole goal was to be able to see the difference between the charts, the graphs, and the equations. Do you think you wrote down enough to understand?
Yes.
Okay.
On